Welcome to our channel Circuits Analytica. In this video, we will discuss a tutorial on nodal analysis for networks with dependent sources. For the following network, using nodal analysis, determine the value of V2 that will result in V1 is equal to 0. We are asked to find value of V2 that will result in V1 is equal to 0. So, set V1 is equal to 0 in the above diagram. Redrawing the above diagram with V1 set as 0. Here the diagram consists of a dependent voltage source whose value depends upon V1. As V1 is equal to 0, voltage source by this voltage source is equal to 0. So let us replace the dependent voltage source with a short circuit. Mark the nodes as P, Q, S and R. Mark the current associated with various nodes as I1, I2, I3, I4, I5 and I6. Voltage at node P is given as 96 volt and voltage at node S is given as V2. So no need to apply KCL at node P and node S. Let us apply KCL at node Q. Various currents associated with node Q are I2, I3, I4, I5 and I6. Out of these, I2 and I3 are incoming currents while I4, I5 and I6 are outgoing currents. So according to KCL we can write I2 plus I3 is equal to I4 plus I5 plus I6. I2 is given as 4 ampere, I3 is equal to Vp minus Vq divided by 20. I4 is equal to 0 as V1 is equal to 0. I5 is given as 6 ampere and I6 is equal to Vq minus Vs the whole divided by 10. So according to KCL, I2 plus I3 is equal to I4 plus I5 plus I6. So Vp minus Vq the whole divided by 20 plus 4 is equal to Vq minus Vs the whole divided by 10 plus 6. Rearranging the terms we can write Vp minus Vq the whole divided by 20 minus inside bracket Vq minus Vs the whole divided by 10 is equal to 6 minus 4. So rearranging the terms we can write Vp minus 3Vq plus 2Vs is equal to 40, equation number 1. Vp is equal to 96 volt and Vq is equal to 0 volt. So from equation 1 we can write 96 plus 2Vs is equal to 40. 2Vs is equal to 40 minus 96. 2Vs is equal to minus 56 volt or Vs is equal to minus 28 volt. So V2 is equal to Vs is equal to minus 28 volt. So when V2 is equal to minus 28 volt, the value of V1 becomes 0. Thanks for watching Circuits Analytica. Enjoy learning.